So, good morning, and my name is Ragavan Ambighananthan, and I'm a principal software engineering engineer in test. I work in Expedia. I've been in this company for the last 7.5 years now, and I'm in this test automation space for the last 15, 16 years. So the topic what we're going to look at today is Selenium Grid based on Kubernetes, Docker, Traefik, and Helm. I call it DA cubes. DA stands for distributed automation. Just raise your hands if you know Kubernetes or if you worked. Great. I think that's a reasonable amount of people. So what we are using at the moment at Expedia is, this is what our current solution, and this is a screenshot from my 2016 talk here, right here in Selenium Camp, and it's distributed automation based on an open source called Selenium Grid Scaler. So what it does is we run our hubs in AWS, and the Selenium Grid Scaler makes your hub a bit more intelligent. It's basically Selenium Grid plus extra some Java code to talk to AWS, and the hub, you can actually request a hub saying, hey, I'm going to run 500 tests. It'll actually create on demand EC2 instances attached to itself, and you can run all your tests in a concurrent fashion. And it has very good termination logic. It can automatically terminate the nodes and etc. And we made lots of improvement as well. And you might ask, are you going to talk about this now? No, I'm not going to, because this is our current solution. It has been working fine for the last 5 years. We run around 90,000 to 100,000 tests a day, and it's been working fine. So you might ask, like, why do you need a new implementation for the same problem? So in terms of speed, for example, what was acceptable 2 years ago wasn't acceptable last year. What was acceptable last year isn't acceptable now, because people's perspective changes, use cases changes. So there are new use cases, like for example microservices, that poses different challenges, and new challenges require new technologies to solve them. And that is what we are going to talk about. So I'm going to take some time to discuss the problems that we have in the current setup for the new challenges. Problem one, our solution, even though it's worked pretty good for the last 5 years, is based on pure EC2 and not container based. And what is the problem because of that? So at the moment, the hub can automatically autoscale the nodes and attach to itself, and you can run tests. But the hub itself, you have to manually create it using a self-service and go and configure your Jenkins job to run your tests against that hub. So hub is not, you can't on demand create hubs and then use it. And the second one is when you use pure EC2 instance, it takes more time to actually create new instances dynamically and run your test. That's problem one. Problem two, microservices. We are all moving from a big monolithic app to taking bits and pieces and creating small services. And with that, when you have small services for a small amount of features, then you make small changes, but you make many changes, because it's, you do bits and pieces and you have CI/CD. And also the attitude towards changing left, which means you test more close to the code than to the release. When I say you test more close to the code, even you test even before you, for example, in Git, even before you merge your pull request, you can take your branch and pass it through your CI/CD, deploy the full stack, run some tests using Selenium Grid, and if you're happy, then you can actually merge your pull request, and then again it will go through the CI/CD pipeline. It's not only a branch, even you can do this for every commit in the branch in Git. And that is where speed of feedback cycle is also important, because everyone wants to know when they make a change, if the change is breaking something as soon as possible, not like after 2 hours or 5 hours, like as soon as possible. So when you pass your changes through a CI/CD pipeline, you expect the results in a most reasonable speed. And one of the blocking or time consuming thing normally is UI test, so you need to parallelize it. And when you move to cloud, you need to see ways to speed up more. Like for example, if you use pure EC2 instance, for example, it's going to take more time compared to container. And dynamic hub creation for each run. So at the moment, as I said, our Selenium hub are manually created using a self-service, and we assign for per team or per Jenkins job. But we are looking at a different perspective now. For example, a team might have 5 engineers, and they are all trying to run their branch through the CI/CD pipeline. And you don't want to share the same hub across all the runs which is going on at the same time. So the approach, what we want to do is, whenever you pass your branch as a approach of shift left, you can just create a hub on demand, use it, and just throw it. And that's what we are looking at. So you just create on the fly. You can run even 300 or 500 test cases and throw it away. So that's that you can't do it right now with our current solution. Problem 3, when companies move to cloud, they initially start with probably 3 accounts: a dev account, a test account, a production account. But when they start hitting problems like rate limit, AWS rate limiter, or running out of IP space, then they start moving to multiple accounts. They pick a logically similar teams and move into different accounts. Now the problem is, your applications, multiple applications, microservices are running in different accounts, and there are shared services that, like Jenkins and Selenium hub solution, Selenium Grid solution, they will be running in another account, and how they're going to access. And private IPs can overlap across accounts. Like as long as you have one AWS test account, it is shared. You can expose a private IP, you can hit that from your corporate network and etc. But when you have multiple accounts, you can no longer, because multiple accounts can use the same private IP address within their space. So that freedom is no longer there. Problem 4, cost. So CPU and memory can be fine-tuned only at instance level when you use pure EC2 as opposed to container. For example, some parameters like CPU and memory are overly allocated at instance level. For example, if I use a C5 large AWS instance for hub, and I know that it doesn't use all the CPU in that box, but it might use a bit more memory. Similarly for node, it may use more memory in a box, but its CPU uses less. But so I'm not making use of the whole resource. But containers, it gives me that opportunity or the flexibility to fine-tune exactly how much you need to give for one browser. So you can, save some money on that. Problem 5 is external traffic. So as you can figure out from the topic that we are going to discuss, Kubernetes. So in the first 4 problems can be solved using Kubernetes, Helm, and Docker. But that gives us another challenge where when you run Kubernetes in the cluster, when you run your Selenium Grid in the cluster, by default you can't allow external traffic inside the cluster. So you need some way to allow external traffic and also have a kind of routing mechanism, because you might be running like 50 hubs. And how do you make sure that when someone's hitting your hub, it goes to the right place? And that's a 5th problem. So this is what we're going to discuss. And if you ask me, like, what am I going to get out of this? I always talk about unknown unknowns and known unknowns. You might, some of you or many of you might have the same problem here, but you didn't know that you can do this way. So that is your unknown unknown. Like now you don't know that you can do this. And known unknown is you can use Kubernetes, but you don't know how. So that's, that, but you don't know. So I'm sure pretty much all of you will fall within either of these buckets. So solution is Kubernetes is for automating deployment, scaling, and management of containers applications. So we are using Kubernetes, and because it can manage your containers, it can pods, and it can restart. It can when something goes wrong. So it takes care of your solution. And Docker is a operating system level virtualization. Of course, Kubernetes uses is a container-based solution. And Helm chart helps you manage even the most complex Kubernetes application. Helm chart is basically like a YAML file where you can specify what how much resources your pod should use and etc. Just as in a file. And the third one is Traefik. Traefik is a reverse proxy. So remember I told you about problem number 5, that you need to allow external traffic to go inside. And also when you use multiple hubs, that's where we are going to use Traefik. Traefik is a reverse proxy as opposed to a proxy, a regular proxy. The server doesn't know who the clients are because every request is coming via a proxy. Reverse proxy is the clients, they do not know which server they are hitting. That's what Traefik is. So the whole objective here is I'm going to share what I learned when I was implementing this, and so you might get some points from on Kubernetes side, from Selenium Grid side, from framework side. So I'm just going to give you a big picture of how a Kubernetes cluster and how with respect to Selenium Grid looks like. For example, here Kubernetes control plane, it's part of the AWS side. It's trying to match the desired state, current state to the desired state of the cluster. Worker node is basically EC2 instances, pure EC2 instances on which everything is running. So there are 2 layers for Kubernetes, right? The actual EC2 instances, and on top of which all your pods, which inside the containers are running. And pod is a concept in Kubernetes. Basically, a pod can run 1 or more containers inside that. Pod is the smallest unit Kubernetes can handle. And kubelet and kubeproxy are basically 2 agents that runs on all the nodes, all the worker nodes. Because for example, kubelet makes sure all your pods are running fine. And as you can see on the slide, the node has the 2 agents running, and you have a pod, and inside a pod you have a container, and that container could be a Firefox browser or a Chrome browser, or it could be any other application. So one of the feedback I got when I submitted the draft slide was people will ask, like, what is Traefik? Why are you using this in context of Selenium Grid? So as I said, it allows you to have external traffic coming into Kubernetes cluster, and also allows. So Traefik is basically, it's not a typical, it's not a regular service. It sits in front of services and acts as a smart router. So I have listed different ways of getting external traffic to Kubernetes cluster, like cluster IP, node ports, load balancer. You can do that, but they are not. They have some disadvantages, either cost or they cannot be productionized. So this last solution, ingress, is what Traefik is a type of ingress, and that's what we are using. And I'm going to show you how it looks. So for example, you send your automation runs to the hub URL. It goes to Traefik, and Traefik has rules, and it can say if the request is coming from host foo.mydomain.com, then send it to a particular service. Service in Kubernetes is basically a service can maintain a collection of pods. Imagine these 3 pods are part of one hub. So I think you will understand more when I show you this. So in this slide, you have 2 hubs. One is hub demo 3 and one is hub demo 2. Hub demo 3 has 3 pods running Chrome browser, and hub demo 2 has 3 pods running Firefox browser. So there are totally actually 8 pods running, because 2 hubs are also pods. And for example, when I invoke hubdemo3.hub.test.expedia.com, how does it know that it needs to go and talk to the service that's running the Chrome pods and not the Firefox pod? And that's what Traefik does. So this is more clear explanation of, so you can see clearly when you hit the hub URLs, there is a rule. This is the ingress rule, where you say that, hey, if the request is coming from hubdemo3. The domain name, and if the path is /, send every traffic to a service name, that particular service. So I have just hard coded it for the sake of clarity, but you don't have to. It's Kubernetes Helm chart allows you to templatize everything. So as you whatever variable you pass, you can replace it in the template automatically. So even if you have 100 hubs, no problem. It knows where to send you as long as you are invoking the right URL. Autoscaling. So in Kubernetes, there are 2 levels of autoscaling, and there are 2 types of autoscaling. Generally, there are 2 types of autoscaling, but in Kubernetes, you have 2 levels. So one is node level. You need somewhere to run the containers. That's a worker node, the PO/EC2 instances. They can autoscale. And on top of them are pods. And inside the pods, containers are running. And they can autoscale as well. So there are 2 levels we are talking about, the PO/EC2, and on top of that, the pods within which the containers are running. So what are the 2 types of autoscaling is horizontal. I've intentionally marked it as green and red because horizontal is you choose the smallest, not smallest, or the smaller meaningful worker node like EC2 instance, for example C5 X large or something like that, and when required you scale it horizontally. You create many of those nodes so you can many pods on top of it. Similarly, if you have an app running, you can replicate the pod so that it can handle many traffic instead of so that is horizontal autoscaling. And vertical is instead of increasing the number of nodes, you increase the size of the node. For example, instead of using a C5 X large box, you might use a C5 2X or 8X large box. So instead of increasing the number of the node, you're actually increasing the size of the node, and in the pod case, you're increasing the size of the pod. And vertically autoscaling is not a good approach, so it's always better to horizontally scale. How I am doing it at the moment in this solution is creating, scaling, terminating Selenium Grid. As you can see that I have striked out the auto because this is not actually autoscaling. This is just scaling because autoscaling has to happen on its own. So here you can actually see this is a command I'm running to create a hub, and based on my inputs in the Helm chart, it'll create a hub with 1 Chrome pod attached to it. And then I realized, like, okay, I need to run, so, and you'll get a URL like this immediately. You can access it. And now I want to create 50 more Chrome pods and attach to the same hub. So I say Helm upgrade Chrome replicas 50, and immediately you will have 50 pods, each running 1 Chrome, or in this case Chrome, attached to the hub. And then once I run the automation against the URL, and I delete the whole stuff, right? So this is what currently our beta solution does. Whenever someone wants to use it, they just follow these 3 steps. And giving you a big picture, as I talked to you about how shift-left approach, everyone wants to run their branches and every commit to the branches through the CI/CD pipeline and run every test. And you can have hubs on the fly for every branch. You can use a git hash of the branch to name the hub. It need not be, you can name it anything, but I'm just giving you a relation between why we are doing this. So every run of your CI/CD pipeline have its own hub. You run it, you create, you run your test, and it's gone. So you can create any, so it gives you the flexibility, so you don't have to worry about sharing and all those things. So I talked about scaling, but there is also Kubernetes allows you to have a feature. It's called horizontal pod autoscaler to actually autoscale. And so real autoscaling is based on observed CPU. For example, if you have a Selenium node, you can tell horizontal pod autoscaler, If the CPU reaches 90%, then keep creating more pods. So here I can say that kubectl autoscale deployment, and if the pod CPU goes to 90%, then keep creating more pods until max is 10. So this way, and after a certain duration, if this CPU percentage is idle, then it will automatically delete. So this is the proper autoscaling. And yeah, and I also want to explain in terms of how the pod level scaling and actual autoscaling using horizontal pod autoscaler works visually. So normally in Kubernetes, you will have a worker node for basic process running, and then once you create a hub based on my input, it will have one hub and one node by default. This is I'm explaining regular scaling, not autoscaling. And when I say I want chrome replica 35 chromes attached to my hub, immediately first thing that will happen is Kubernetes will know, oh, I need to create 35 pods. Let me autoscale the worker nodes, because you need somewhere to run those pods, and it will autoscale the worker nodes. And once your worker nodes are up and running, then you have the pods running on top of it. So here you autoscale the worker node, but the pods were scaled, and once you run the test, you say purge my release or purge my namespace, it's gone. Once and now once your pod everything is deleted, now your worker node, you don't need them because there's no pod to run, so they will scale down, they will go away. So this is scaling. I want to show you how the autoscaling works in using horizontal pod autoscaler. That's a feature of Kubernetes. So I can say that kubectl autoscale, say CPU percent 90. Whenever a pod reaches 90 percentage, it will start creating more pods with between minimum and maximum. So it's the same way. You have one worker node. I want to create a hub. It starts with one pod, and now it's starting to create pods. So you can see that I couldn't make the graphics pretty good, because actually what's the big difference is the previous solution. If you're running 500 tests, and if it takes 5 minutes or 10 minutes, you had to wait that 10 minutes before you can destroy the whole stuff, and then the worker node also scales down. But in the real autoscaling, what will happen is, imagine you have 500 tests. Not all the tests are going to take 2 minutes or 5 minutes. Some might finish in like 30 seconds, and some might take 3 minutes. So if the majority of your test takes only 30 seconds, why you need to waste resources for the rest of the 4 minutes when the slow tests are running? So with this approach, when the pod that's running a faster test is finished, due to using some fine tuning of how long it needs to be there, it can go away when other pods are running like this. And now that work node is no longer necessary. It can be scaled down. So just a disclaimer, I'm still trying to make this properly work, because you need to fine tune lots of parameters to actually make use of it. But this is the optimal solution than scaling, because of the flexibility it gives you in saving some money here. Also, another this is warm worker node pool. Basically, what this is about is you have when you start with Kubernetes cluster and there's only one team using it, and say imagine their CI/CD pipeline runs like 10 times a day. Every time you want to run automation and you send a request to give me a hub with 30 pods running from Firefox, it actually has to create the EC2 worker node and then create the pods. So it is going to take some time when you're only one team that is using your cluster. But when many teams are using, and they will be running at different intervals, and your worker node will be always warm. It means there will be some worker nodes, so when you say create, it's going to be very quick. And that's the whole purpose we're using container-based solution. Also, we are using Traefik, and it is HTTPS. So the hubs will be HTTPS based. And one thing we learned was, for example, in Nightwatch, if you use Nightwatch.js, this is the configuration you should set. The Selenium port to 443 and use SSL to true. And for other framework, you can just pass the /d hub URL, and without having to pass 4444 port. And yeah. The other one is resource quality of service. In Kubernetes, this is a concept, and it has three different types. One is called guaranteed, other one is burstable, and best effort. I'm going to just talk about guaranteed because that's what I'm interested in, because guaranteed QoS gives you a stable Selenium Grid solution. What is guaranteed is how can you make your hub or your Selenium solution guaranteed? In when you use Helm chart, you will say for each Chrome pod or Chrome container or Firefox container, how much memory and CPU should it use, and you can say how much it can request and what is the maximum it can request. That is the limit. If you want your pod to be guaranteed QoS, make sure these two values are always same. Whatever you give to request, give that to limits as well. And why do I need guaranteed? Kubernetes has a policy of eviction. If a node is running many hubs, many pods, and if the worker node is running out of memory, it has the policy to evict a lower priority pods and put it to another worker node. But if a pod is marked as guaranteed, it will be the last pods that will be evicted in case when there's no resource available in a particular worker node. And this is also an important thing to understand deeply about how everything is working. As I said, Kubernetes, you have a worker node, and the worker node always run two agents, kubelet and kubeproxy, and you have to reserve some memory for them so that they are the lifeline. If those two processes goes down, there's no point, everything will fail, whatever is running on that worker node. So you need to allocate enough memory, and for system reserved is for kernel and system processes. And also you specify an eviction threshold, and the whole resource of memory and CPU minus this is what the pods can actually use for running Chrome and Firefox browsers. So eviction hard describe a set of eviction thresholds. So we can say that as you can see here, memory available less than 512, then the eviction policy will kickstart, and it'll look at lower priority pods, and then it'll try to move that to a different node, different worker node. And you can actually see you can reserve memory for system and kube related processes, and I'm saying memory use 1 GB is basically is not 1 GB, is 1 GB minus eviction hard. So if your system processes takes more than 512, the eviction process will kickstart. Or if your pod that you allocated a memory is using more than that, eviction process will start. This is important to understand because sometimes you might see that, oh, okay, what's happening? I'm not able to reach my hub. Suddenly something happened. This might be the reason. So as I said, I'm just sharing what I learned the hard way. I'm sharing you all the things I learned. Yeah. Somewhere I saw in Selenium, I think in some Git repository, that the best practice is to use one browser in one pod. I think that's true. And also it's cost effective. You can run many containers in one pod. There's no restriction. But imagine you want to, let's start with the first case. You want to run one test. Will you create one pod with one Chrome or one pod with two Chrome? There's no use because you're wasting resources. And so it's better to have one pod per browser. And also it's suitable if you use horizontal pod autoscaler feature as well. And I mean, if you have listened to my 2016 talk about distributed automation, I would have mentioned that when you have hubs and nodes running in different subnet, you always get this error, forwarding to node failed. But I didn't see that problem in Kubernetes, because in Kubernetes, when you create the cluster using CloudFormation, minimum you have to give 2 subnets. And I was like, oh my God, this is the actual problem that is going to cause a Selenium hub solution. And it didn't. Things are working fine so far. This is another problem I faced when I tried, because in Kubernetes, the beauty is you can just quickly switch to the latest browser and latest Selenium WebDriver, because they're all Docker images. And when I'm using the latest one, and I could see sometimes it's not reliable because I'm not saying Selenium WebDriver is not reliable. I think they at one point they switched from Apache to OKHttp. And so if you want to switch back, that's how you do it, and it's stable now. This is another thing I would like to just as an FYI share it with Selenium folks who always do an awesome jobs of creating this open source that everyone is using. So going back 2014, 15, a pure EC2 instance, I was able to run 15 Firefox instances in one box, which is C5X large. And only 10 because every Chrome browser runs an associated Chrome driver, right? After we moved to Selenium 3, and when Firefox introduced Gecko driver, I was able to run only 10 in the same type of box where I used to run 15, right? And now when I go to Kubernetes, with the same type of box, I can run only like 8. So if you look at the test pyramid, the UI test is at the top because it's costly and it's highly brittle, and that's why we want to have smaller number of UI tests. And looking at this, the cost is going up because of associated WebDriver and etc. But I also thought, like, okay, I should probably stop using C5X large because it's compute optimized. I should use M5, which is memory optimized, because browsers needs more memory than CPU, and try if it makes a difference in numbers. So I will update probably in the next presentation or somewhere if it makes any difference. I didn't see any big difference between headless and regular browsers. I think there is probably people confused, like, okay, if it's headless, it's going to be very lightweight. It does render your page in memory, and I run the same test. It takes the same amount of time, or probably plus or minus. Only benefit is if you're running locally, you don't see any browser opening and closing. It doesn't impact your, it doesn't distract you. Also, if you run it on headless, then you can actually switch off XBFB process. Just save some resource. This is an important thing I learned. Like it came out as a surprise. Prevent IP address bleeding. What is the problem here is Kubernetes reserves a set of IP address per worker node, per instance, when it creates a worker node. So, for example, C5X large, it immediately reserves 30 IP address per worker node, even when no pods are running. So I was trying to scale my solution to 300 pods, running 300 test cases, and I had around 800 free IP address, and suddenly it's 0. And I was like, what happened? And then I figured out that this is how it works, and and there is a way to prevent this from happening. Is basically there's an environment variable called warm IP target. In my case, I know my hub, one pod for running Chrome, take this much memory and this much CPU. Then I can calculate how much pods are going to run in one box. Then I can set it to 10 or 11. It's not going to be like Kubernetes can still override you and say, hey, I can run more pods than 10, and it will dynamically get an IP address. But this way, you don't bleed out of IP address, because you can easily do that. Can easily happen if you don't do this. And job type is another thing I learned, is that Kubernetes has different ways to deploy your application and the pods and everything. And one of the type is job. Imagine you have you know that your automation takes only like 5 minutes or 3 minutes. It's very consistent. If your job deployment type is that much time, then you can say, hey, after 3 minutes or 5 minutes, just destroy the whole stuff automatically. You don't have to delete and purge the release and etc. It'll just go away on its own after the deadline. So this is good for like batch process and etc. That's pretty much. And thanks for listening to me. And I try to put all the things I talked about in my Git repo. Go and take a look. It might not work straight away because you need to set up, you need to get your subnet, and you need to put your IP address and everything in the files. But otherwise, it's very straightforward. You can try. This is very specific to AWS. But so if you're using Google Cloud or something else, the concept is same. There might be slight differences. So thank you.
Thank you very much for your speech. A question about test results. How do you gather, store, and analyze test results from such huge amount of Selenium tests? Thank you.
Good question. So the question is, how do I store and analyze test results when you run huge amount of tests? What we do is we have like Water WebDriver framework based on test based on Water WebDriver in Ruby. We have we use Nitro.js, we use Scala test. For every framework, we have a module that will run after automation is completed. That modules are written by us, and what they do is it goes and collect all the artifacts, and we also have our custom formatter, which means every test will have its own HTML results, HTML report. So we get all the artifacts, HTML logs, what error happened, what was the error on the page when the test failed, screenshot. If you have Splunk kind of log, what is the link to that Splunk log with that particular when that error happened? What is the log in your system? We store everything, and we built a dashboard using a Node.js app. And we tell all the teams, like, you don't have to worry about going and checking your Jenkins. Go to the dashboard. You can actually see a trend for the last 21 days, how your test for each project is doing. And now we thought like maintaining an app for that is kind of becoming more work. And so we are now trying to put all the results, the same results, instead of MongoDB. So all the results are put to actually Mongo so far. Instead of moving to MongoDB, now we are pushing everything to Elasticsearch and then using Kibana. So there's less work of developing different UI, because Kibana allows you to have the flexibility, and you can create trends and everything, and people can actually see when things fail, because they can see a trend. That's the beauty of storing data. You can see a trend, and when something is wrong, you see, oh, okay, why suddenly there's a red. So that is how we are doing.
Thank you for speech. It was awesome. I have one strange question. Is there any chance, is it reasonable in terms of running tests in Kubernetes to use spot instances of AWS? If there is no sense, what is the difference between like regular instance and spot instances in terms of running automated tests?
So my knowledge on spot instance, I think one of the fact of spot instance is they can take away that instance with very short notice. I think 1 minute or 2 minutes, because that's a concept of spot instance. So if you are running your automation on spot instance, obviously it will save you money. But if you don't worry about once in a while, those boxes are terminated when your automation is running, and if you're not worried about it, then you can use. I asked the same question when I was in Las Vegas for the AWS reInvent. I asked him statistics to one of the AWS folk. I asked him, how often when people use spot instance, do you have a statistics how they were earlierly terminated as the concept of spot instance is? And he gave me a statistic something above 90%. Above 90% of time, it doesn't happen to anyone. Like nobody sees that, oh, I'm using and it's gone. So it happens like probably 10% of time. So I mean, I would like to try that as well. Yeah. Yeah. Yeah, there's no harm in, obviously it's going to reduce your cost. Yeah.
Were there a situation where you had to, well, like some test failed and you didn't know why, because it runs locally, for example, very good, and then it fails constantly or from time to time using cloud, and you got all your instances terminated after execution. So did you run into such situations? How did you debug it, solve it?
So because we store all the data, like one of the goal we had was run automation within the time taken by the slowest test case, like how fast you can run. That was our goal. And now our goal is, as you said, how we can reduce the analyzing test failures to zero. Like you don't want to spend more time keeping analyzing test failures. To answer your question, we store whatever data available when a test fail into Mongo or Elasticsearch, including, for example, you go to our site Expedia or any site and you're running automation, and when the test fails, we also read the HTML and see what was the error shown, and we also store that. So we pretty much have so many data points that we can conclude this is why the test failed. But we don't have video recording yet, but even if you have video recording, that will helpful. But you're right, because those nodes will be gone, so there's no logs and other things. But we have the ability to store the network request. For example, we use browser map proxy. If you choose, all the automation will go through the browser map proxy. We get the whole network log and store it as well, and you can actually look at it and see what happened.
Very nice, thanks.
Thank you, guys. If you have any questions, just